Alright guys, so we were streaming, but for some reason the streaming wasn't live, but we advanced half of this chapter. Now we're about to finish this chapter. I'm just gonna stream the last part. So I'm gonna check the audio now. And the audio is also not appearing, but why? Hello, hello? Now you can hear me? Or maybe it's because I need to put correctly this. Or maybe because I need to... Alright, now it's good. Now let's just finish this.
Storing and retrieving this information using vector databases. We've now loaded documents and split them into chunks using an appropriate chunk size and chunk overlap. All that's left is to store them for retrieval. We'll be using a vector database to store our documents and make them available for retrieval. This requires embedding our text documents to create vectors that capture the semantic meaning of the text. Then a user query can be embedded to retrieve the most similar documents from the database and insert them into the model prompt. There are many vector databases available in Langchain. When making the decision on which solution to use, consider whether an open source solution is required, which may be the case, and high customizability is required.
It's really interesting because databases that support vector search, you have the OpenSearch, Click, Postgres, Cassandra, Elasticsearch, Redis, Rocket. Is source available or commercial? Open source. So I guess that most of the startups are going into these ones. I personally use MongoDB, so I guess that I'll need to check.
Also, consider whether the data can be stored on off-premise on third-party services. Not all cases will permit this. The amount of storage and latency of retrieving results is also a key consideration. Sometimes a lightweight in-memory database will be sufficient, but others will require something more powerful. In this course, we will use ChromaDB because it is lightweight and quick to set up. We'll be storing documents containing guidelines for a company's marketing copy. There's two guidelines, one around brand capitalization and another on how to refer to users. Now that we've parsed the data, it's time to embed it. We'll use an embedding model from OpenAI by instantiating the OpenAI embeddings class, passing in our OpenAI API key. To create a Chroma database from a set of documents, call the fromDocuments method on the Chroma class, passing the documents and embedding function to use. We'd like to persist this database to disk for future use, so provide a path to the persist directory argument. Finally,
okay, well now we're gonna use the Chroma database. This is local, we already have it installed. And
to integrate the database with other Langchain components, we need to convert it into a retriever with the asRetriever method. Here, we specify that we want to perform a similarity search and return the top two most similar documents for each user query. So the model knows what to do. We'll construct a prompt template, which starts with the instruction to review and fix the copy provided, insert the retrieved guidelines, and copy to review, and an indication that the model should follow with a fixed version. To chain together our retriever, prompt template, and LLM, we use LCell in a similar way as before, using pipes to connect the three components. The only difference is that we create a dictionary that assigns the retrieved documents to guidelines and assigns the copy to review to the runnable pass-through function.
Okay, give me 1 second.
Review and fix the copy provided, insert, which starts with the instruction persist components. We need to convert it into a retriever with the asRetriever. So the model knows what to do. We'll construct a prompt template, which starts with the instruction to review and fix the copy provided, insert the retrieved guidelines, and copy to review, and an indication that the model should follow with a fixed version. To chain together our retriever, prompt template, and LLM, we use LCell in a similar way as before, using pipes to connect the three components. The only difference is that we create a dictionary that assigns the retrieved documents to guidelines and assigns the copy to review to the runnable pass-through function, which acts as a placeholder to insert our input when we evoke the chain. Printing the result, we can see the model fix the two guideline breaches. Let's cement this with some exercises.
Okay, got it. So in this case, so over the next exercise, you will build a RAG conversation with RAG fast pipeline trade-offs, case study, and okay. This is a document. So I will use the recurse text splitter. I'll put the chunk size of the 300. The chunk overlap is gonna be 50. Then I split the documents. I use the embedding functions to create the I think it's create, because with this here we sorry, with this here we create the case should be 3 of similarity, so the first 3 the vector store is like dogs from the current is a vector database. So here I split. I create embedding function, I pass the embedding function, I create a ChromaDB with the dogs that I just splitted. Then I create a retriever function. So I just copy this, run and submit. All right. So I'm gonna do this into, it's gonna be here. New file is gonna be file rock vector db, and this is gonna be .py. And here what we do is we do here. Then in the next one we return prompt, chat prompt template from messages. Complete the message string to add a placeholder. Dynamic insertion of the retrieved documents called context. So this should be context, and this should be question. From messages with the human role. So in this case, this is going to be in here, and creating a rack chain. So in this case, we create a LCell. So from the documents, I get the retriever. From the prompt template, I pass the context, which is the okay, this rack chain is invoked. The question, the context is gonna be the here the retriever, and in here and I'll take a hint just here. So I should just pass the pass through, which is gonna pass this into the question directly. So the question is gonna be this, The retriever is gonna retrieve the document, so I should do the retriever. I think in the embeddings, in here there was a retriever. So if not in here, then in here it was retriever dot. Okay, now let's run the code then. Probably it's gonna throw me the error here because this is not just gonna be a retriever. Or is it? Or I can actually. I don't know. Let's figure it out. So technically I can just pass the retriever. So this is really good. And really easy actually. Compared to the things that you need to do massively in JavaScript. Nice. We finished this. Thank you very much, guys.
Congratulations on completing the course. Let's wrap up by reviewing what you've learned. We started by talking about the core components of Langchain: models, prompts, chains, agents, and document retrievers. We used open source models from Hugging Face, as well as proprietary models from OpenAI. We learned how to combine models, prompts, and agents using LCL chains. Finally, we learned how to integrate external data into LLMs, overcoming the limitations of their training data. As you continue your Langchain journey into AI application development, the Langchain Hub will be a fantastic resource along the way. The Hub contains a catalog of prompts for a whole range of different tasks. You can search, use, and add to this massive catalog as you progress. Langchain templates are also worth investigating. There are sets of code blocks that are ready to use out of the packet, and they cover many of the most common use cases. They may require minor modifications or additions, but they're often the best place to start. The core Langchain package that you've seen in this course is only a piece of the full Langchain ecosystem, which also includes Langsmith, Langserve, and Langgraph, as you've also seen in this course. Langsmith is used for troubleshooting and evaluating LLM applications, and Langserve is used for deploying these applications to production, while Langgraph, as you know, is used for multi-agent knowledge graphs. Continue to explore these tools as the ecosystem evolves. Your journey is only just beginning, so onward.
Nice, guys.
Congratulations on completing the course. Let's wrap up by reviewing what you've learned. We started by talking about the core components of...
We finished this whole mini career. So now it's time to... Yeah, I know it says incomplete because this is like... I just want to... This is the course that I just... the data camp, like... environment wasn't running that day. So I need to just finish that, and then I'm done. And then I'm gonna start tomorrow with the projects. I think I'm gonna make a recreation of this whole course, but with a chatbot. I'm gonna make it with Python in the backend and with React in the front end, maybe next. And then I'm gonna figure out what other things I can do. Maybe I can do a small project for the music, because I'm also DJ. And I have some in the dashboard I might show you another day. And then also some open source contributions, and then I need to do some other projects for a company. So thank you very much. We finished. Now we are AI engineers.